In earlier lessons, you learned how to control turns using encoders. This works because there is a direct relationship between how much the wheels and encoder spin and how much the robot turns. You may have noticed that sometimes these turns don't always work perfectly or consistently. Occasionally, the wheels may slip or stick, causing the robot to turn too little or too far. This effect can be frustrating, throwing off every subsequent movement the robot makes. This effect, where the robot gets further and further off course, is often called accumulated error. The VEX gyroSensor is excellent at reducing accumulated error. Rather than relying on the relationship between the wheels and encoders to control the turns of the robot, the gyroSensor can measure the rotation of the robot itself. Even if the wheels slip or stick, the robot can be programmed to turn until it has reached a certain heading. The gyroSensor is an analog sensor and reports how much the robot has turned in tenths of degrees. This means that if the robot has turned 10 degrees, the sensor will have a reading of 100. The gyroSensor can also tell the difference between clockwise and counterclockwise turns. The sensor value will increase when the robot turns counterclockwise and decrease when the robot turns clockwise, along the axis indicated by the curved arrow on the sensor. All of these capabilities are possible because the gyro is a MEMS motion sensor, a micro-electromechanical system. The sensor contains a metal ceramic mass with a crystalline structure that contracts slightly when an electrical voltage is applied. When the voltage is removed, the material expands back to its original size. By putting the mass on a spring and switching the current on and off repeatedly, the mass is made to vibrate back and forth along a straight line. Moving objects like the vibrating mass tend to keep moving in the same direction, unless an outside force pushes them in a different direction. When the sensor is rotated, the crystal mass tries to keep moving along its original line. But that direction is no longer in line with the rest of the sensor's body. The gyroSensor measures the amount that the mass is out of alignment with the rest of the sensor's body, and a second mirrored setup facing the opposite direction allows the sensor to cancel out non-rotational forces.